We'll now begin section 6.2. In this section, we will discuss the 6 basic trigonometric functions. These 6 basic functions will be used throughout the semester. These functions are the sine, cosine, tangent, cosecant, secant, and cotangent. To define these functions, we use a right triangle. Remember that a right triangle is a triangle with a right angle. We're also going to label one of the other 2 angles. It does not matter which angle you label. We can use the one at the top of the triangle or the one at the bottom. In this case, I'm going to go ahead and use the one at the bottom. So we're going to call this angle theta. As we define the 6 trig functions, we will define them in relation to angle theta. Now we know that on a right triangle, that the slanted side, the side opposite the right angle, is called the hypotenuse. So I'm going to label this side as the hypotenuse. And from this point on, I'm going to denote that with a capital H. The other 2 sides, we're going to label one side the opposite side and one side the adjacent side. So as I look at my angle theta, I'm going to use the word opposite for the side that lies across from the angle. So if my angle is here, the opposite side is over here. And we're going to denote that with a capital letter O. The word adjacent means next to. So again, in relation to my angle, I am going to say that the side underneath is the side that is next to the angle, and we're going to call this the adjacent side. And we'll use a capital letter A to denote that. Now, again, the position of your opposite and your adjacent side depends on where your angle theta is. For example, if I were to have drawn a right triangle and placed my theta value here, my hypotenuse would still be the slanted side, but where would my opposite side be? The side opposite this angle would be here, and therefore the side next to it, the adjacent side, would be here. So keep in mind that your opposite and your adjacent sides are not fixed, but they are determined by the angle that you use for theta. So let's go ahead and define now our 6 trig functions. Our sine function, we are going to denote as SIN, that's the abbreviation for sine, and anytime you use a function, you're also going to use a corresponding angle. So we're saying sine of theta, and the sine is going to equal the opposite over the hypotenuse. And so I'm going to abbreviate O over H. For the cosine, we will abbreviate COS and use our angle theta, and we're going to say that by definition that is the adjacent side over the hypotenuse. And our tangent function, we'll abbreviate TAN of angle theta, and that's going to be the opposite side over the adjacent. Now, it is very important that you memorize these definitions for sine, cosine, and tangent. Oftentimes in a high school class or a previous class where you may have discussed these trig functions, you will be told to use this saying, SOHCAHTOA. So you may have heard this before. This is a good way to remember which trig functions go with which sides in your right triangle. For example, the S stands for sine, and sine is the opposite over the hypotenuse. The C stands for cosine, and cosine is the adjacent over the hypotenuse. T stands for tangent, and tangent is the opposite over the adjacent. So if you find that memorizing is difficult, you may try the SOHCAHTOA to help you remember the trig functions. Now, as far as the other three functions go, the cosecant, the secant, and the cotangent, they are simply reciprocals of these first three. So we will abbreviate cosecant as CSC, and it will be the reciprocal of the sine, so it will be H divided by O. For secant, we will abbreviate that function SEC, theta, and it's going to be the reciprocal of the cosine, so H divided by A. And for cotangent, we'll abbreviate COT, and it's the reciprocal of the tangent, so A over O. So now that we have defined our 6 trig functions, we're going to look at a couple of quick examples as far as how to use these definitions. So our example says, use the information contained in the 2 figures below to determine the values of the 6 trig functions of theta. And we're given 2 triangles. Now, the first example is much easier than the second, so let's begin there. All right, remember that our directions ask us to find all 6 trig function values. Now, notice that we have 2 sides that are given. Our angle theta is in the bottom left-hand corner, so the 4 is the opposite side. It is the side across from the angle. So I'm going to go ahead and label this the O. The 3 is the adjacent side. It's the side that's next to the angle, and so I will name this the A side. And we need to find the hypotenuse. So remember that when you're working with right triangles and you need to find a missing side, you can use Pythagorean theorem. So we can set this up and say a squared plus b squared is equal to c squared. Now remember that the a and the b are your legs of your triangle, and it doesn't really matter which one is which, but the c is your hypotenuse, the slanted side that we're looking for. So I would say 3 squared plus 4 squared, using the sides 3 and 4, is equal to c squared. 3 squared is 9, 4 squared is 16, 9 and 16 make 25. And so you can see by taking the square root of both sides that our missing side is equal to 5. And this is our hypotenuse, so we'll label that H. All right, so the next thing that we need to do is we need to take our definitions for our trig functions and plug in. All right, so remember that our sine function was, and I'm going to write my SOHCAHTOA here so I can remember which way it goes. So remember that your sine function was your opposite over your hypotenuse. So we're going to do opposite is 4 and hypotenuse is 5. So the sine value is going to be 4/5. Cosine is the adjacent over the hypotenuse. So A would be 3, hypotenuse would be 5, and the cosine value would be 3/5. Our tangent value is opposite over adjacent. So 4 over the adjacent 3. So our tangent function is equal to 4/3. Remember that the other 3 functions are reciprocals. So our cosecant would be the reciprocal of 4/5, which would be 5/4. Our secant function would be the reciprocal of the cosine, so 5/3. And our cotangent function would be the reciprocal of the tangent, so 3/4. Let's move on to part B. So part B is a little bit different in that they give us two of the angles instead of giving us any of the sides. So we need to notice that we have a 90-degree angle here. Remember that pi/6 is an equivalent to 30 degrees. Remember, 30 degrees and pi/6 are the same angle, one in degrees and one in radians. And so the missing side on this triangle, remember that the angles have to add up to be 180 inside a triangle. So we have 90 and we have 30. So the other angle has to be 60, or pi/3 if we were looking at it in terms of radians. Now, the thing that you need to remember from maybe a geometry class is that the sides in a 30, 60, 90 triangle have a certain ratio. All right, so I'm going to make a note up here because I'm not sure that this is always something that we do remember. All right, so 30, 60, 90, the sides have the ratio of 1 to the square root of 3 to 2. Okay, so what this means is that, and these are in respective order, so that means if the side opposite your 30-degree angle is 1, so I'm going to go ahead and opposite this 30-degree angle, I'm going to put a 1. The side corresponding to the 60-degree angle will be square root of 3. So across from the 60, we're going to put square root of 3. And across from the 90-degree angle, we're going to have a side of 2. Now, it doesn't always mean that the sides have to be those exact values, but they do have to have that relationship. So, you know, it's possible for the numbers to be different and the relationship to hold, but this is the most simplified form of that relationship. So once we know that, then we can go ahead and determine what's going to happen for our trig functions. So again, we are looking for the trig functions of angle theta. So down in the bottom left. All right, and again, I'm going to write down my SOHCAHTOA just so I can remember the relationship. All right, so sine is going to be opposite over hypotenuse. All right, so we're going to do, remember your angle's down here at the bottom. Here's your angle that we're looking at. So opposite is going to be square root of 3. Hypotenuse is going to be 2. All right, for cosine, we're going to do adjacent over hypotenuse. So adjacent will be 1. Hypotenuse will be 2. And tangent is going to be opposite over adjacent. And we know square root of 3 over 1 is going to simply reduce to square root of 3. Cosecant, which will be the reciprocal of the sine. Now, you have an option here. The reciprocal of the sine will be 2 over the square root of 3. Now, in most cases, we are going to be asked to rationalize that so that we don't have the square root of 3 in the bottom. And so we might want to come off to the side somewhere and look at that. All right, and so remember that to rationalize it, you need to multiply top and bottom by square root of 3. And so 2 times the square root of 3, and the square root of 3 times the square root of 3 will just be 3. All right, so we could write this as 2 on the square root of 3 over 3. All right, for our secant, that one's a little bit easier. For our secant, the reciprocal of 1/2 will be 2. And for our cotangent, again, we're going to need to do a rationalizing on the denominator. Remember, this was the square root of 3 over 1. So when we turn it over, we're going to have 1 over the square root of 3. And when we rationalize that, we're going to multiply top and bottom by square root of 3. It's going to give me square root of 3 on the top. Square root of 3 times square root of 3 on the bottom will give me 3. And that completes example B. All right, let's look at one more example. This one asks us to find the tangent and the secant of an angle pi over 4. All right, so let's go ahead and draw our right triangle. We'll put our right angle here, and we're going to put our pi over 4. Let's put it up here at the top. Now, remember that pi over 4 is the same thing as a 45-degree angle. And note that if you have the 3 angles, you have a 90 and you have a 45, that the other one also has to be 45 so that the angles will add up to be 180. So you're also going to have a 45-degree angle down here. And just like we saw on the 30, 60, 90 triangle, a triangle that has 2 45-degree angles and a 90-degree angle is going to have a special relationship with the sides as well. And so let's jot that down so that we remember that. So if we have a 45, 45, 90 triangle, then the ratio on the sides is going to fall in the relationship of 1 to 1 to the square root of 2. Now, basically the easiest thing to remember here is that the sides opposite your 45-degree angles have to be equal. So again, it doesn't have to be 1, 1 and the square root of 2, but it does have to hold that relationship. So across from the 45 at the bottom, we're going to put a 1. And across from the 45 at the top, we're going to put a 1. And across from the 90, we're going to do a square root of 2. So now that we have all 3 sides of the triangle labeled, we can go ahead and find what they're asking for. They're asking for tangent theta. Remember tangent, SOHCAHTOA. Tangent is opposite over adjacent. So using our angle at the top, which is what we said we were going to look at, although you could also use the one at the bottom, the opposite side is 1. And the adjacent side, the side next to, is also 1. So tangent of our angle is equal to 1. All right, let's look at the secant of this angle. Remember that secant is the reciprocal of cosine. So we know that cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So the hypotenuse will be square root of 2, and the adjacent next to it will be 1. And so again, simplifying just a little bit, we have that the secant is equal to the square root of 2.